Okay, this is your support video for Chapter 6, Day 9. You're going to get two of these. You're going to get Day 9 and Day 10. Those are the main ones that you need before you can work on your own. Okay, this is about the binomial distribution. Okay, binomial means two. There's only two outcomes. They call those two outcomes success or failure. Okay, even if it's something strange, like probability of making a free throw is obviously success, missing is a failure. But you could have anything that's just P and 1 minus P. Okay, there are four things that make a binomial. It's another acronym for you. And the acronym is POTTY. Okay, there are two things that can happen on the POTTY, I guess. And there you go. Okay, so probability of success is consistent. That's P. So when you get into those small sample sizes where you violate replacement laws, those are not binomial because the probability is changing too dramatically. But when you have super massive amounts of samples or something like rolling a dice where the probability is always 1/6 of getting a 1, for example, then you're into consistent probability. Free throw shooting would be considered consistent probability, for example. Okay, only two outcomes, success or failure. Okay, that's probability of it happening and not happening. Rain, not rain. Okay, number of trials is fixed. We're only going to examine 5 days of rain, not rain, 10 free throws, anything that's fixed like that. And then each trial is independent, meaning they shouldn't have an influence. And free throw shooting for this class will be considered independent. One shot shouldn't affect the next, even though you could argue that it is different because people are learning from their previous shot, etc. We're going to say that that's going to be fixed. Okay, studies have actually shown that they're pretty independent. Okay, so we're going to read these. I got the answers, and you're going to try to react if these are binomial or not. Mr. Nguyen randomly selects 80% of the homework assigned. What is the probability he collects all the homework this week? All right, here we go. He collects 80% of it. That's consistent, okay? There's two outcomes. He collects it or he doesn't collect it. There's a set number of trials. The week, I'm presuming, is 5 weeks. And each day, his decision is independent. That's considered binomial. And it's not uncommon on the AP test that you are required to write out the assumptions for a binomial in context of the problem. So please do that if you make a decision that something is binomial. Okay, how many text messages will you receive within the hour? That's not independent. Probability of it getting a text or not, that's fine. The outcomes are fine. Probability is going to be changing all the time on this because it depends if you sent a text out. If it's 2 in the morning, all that stuff is going to be different. So this one doesn't meet the very first requirement, okay? All right, you can answer 75% of any math problem. How likely is it you won't get a correct answer to the fourth question? Well, probability is the same every time, 75%. There are two outcomes, you get it right or not. But this does not have a set number of trials. You are just trying to figure out when you answer your first question correct. How long do you have to wait until you answer your first question correctly? That's called a waiting time distribution. That's the geometric distribution. That is the next section that we study and the final section of this course, okay? Okay, now here's your formulas, okay? You're very unlikely to use this formula, but this is from Pascal's triangle, NCX, that's from Pascal's triangle. I will be doing this alongside the other problems when we do this, okay? So here's your formula for Pascal's triangle purposes for calculating a binomial distribution. Q, as a reminder, is 1 minus P. X is the number of trials, and minus X will be the number X is successes. X is successes. N is number of trials. And then N minus X will be the failures, okay? So this is all gonna play out here. This is your expected value, N times P. This is simple. If Johnny shoots 10 free throws and he's a 70% free throw shooter, the normal amount he'll make out of 10 is 7. 10 times 0.7. And this is your standard deviation. NP 1 minus P, also called Q. All right? So we're going to be able to do stuff on your calculator, okay? This function is located in second distribution, okay? And when you press that button, you're going to see binomial PDF and CDF. PDF is exactly one trial. CDF is the or less function, okay? So if you want the probability of Johnny making exactly 7 out of 10 free throws at a 70% shooter, then that's going to be the PDF function. If you want the probability of making 7 or less free throws out of 10, that's a CDF function, okay? And all of this I'm going to explain in context. If you don't have a graphing calculator, I will show you alternative ways to do this, okay? Okay, here we go. Approximately 15% of males are left-handed. Find the probability that in a group of 16 randomly chosen males, there are exactly 3 lefties. Okay, this is how you would do this with Pascal's triangle. Okay, so you would go 16 choose 3. Okay, 16 choose 3 times 0.15 to the third times 0.85 to the 13th. That's the long way to do that. This 16 choose 3 you can get off your calculator. It's 16 math probability NCR and then hit the number 3. Okay? And then this is 0.15 to the third, exactly 3 lefties and exactly 13 righties. Righties is considered failure in this case because it's 1 minus the lefties. Notice that these add to 100% and these two numbers add to the sample size, which was 16. This is binomial, meets all the requirements. Probability is the same every time, 15%. There's 2 outcomes, left-handed or right-handed. 16 is the trial, okay? And everybody's independent whether they're left or right-handed, okay? So it meets those criteria. I'm going to show you in a little bit how to put this on your calculators or the whole distribution. It's really cool. Okay, exactly 5 lefties, no problem. Exactly 5 lefties will be 16 choose 5 times 0.15 to the 5th times 0.85 to the 11th. Okay, pretty simple. Of note, sometimes the AP test does it this way. That means 16 choose 5. That's another notation you could see. 16 choose 5 as opposed to that, okay? Or you can plug it in your calculator, binomial PDF, number of trials, probability of success, and how many you're looking for exactly, okay? All right. At least 5 lefties. At least 5 lefties. This is a case where doing this by hand would be absolutely ridiculously impossible. You have to do it with the distribution, okay? So, let's look at this. At least 5 lefties. At least 5 is 5 or 6 or 7 or 8 or 9 or 10, all the way to 16, which is a lot of work to do by hand. But what you can do, at least 5, the complement of at least 5 is 1 minus 4 or less. So I'm going to combine 4 or less, which is 4 or 3 or 2 or 1 or none. Okay? And that's going to be done here. Binomial CDF. I'm accumulating and adding up the or less function of the calculator. So that's 16 trials 0.15 is the number of, its probability of success, and 4. Once I gather together 4, 3, 2, 1, and 0 trials, their probabilities added up, I can go 1 minus, and I'm going to be left with at least 5 lefties. I'll show you a different way to do this later on in this period, okay? All right. And now I'm going to do no more than 3 lefties. No more than 3 lefties means 3 or less. So I need to add up probability of getting 3 or 2 or 1 or none. 3 or 2 or 1 or none. Okay, that's 3 or less. And 3 or less will be simply binomial CDF 16.153, and that'll add up to that, okay? What is the mean? Now the mean of this is just going to be n, the number of trials, 16, times the probability of success, 0.15, and that's going to give me 2.4, okay? And the last one is what is the standard deviation of this? The standard deviation, again, will be square root of n times p times 1 minus p, and there it is. So the average number of lefties in a group of 16 is 2.4, and it'll deviate by about 1.4 on average from 2.4. Okay? All right, next set. Okay. In a given city, the estimated rate of DUI-related accidents is 2 out of every 15. Find the probability that in investigating 12 accidents, there are exactly 6 DUI accidents. Exactly 6. You see how to do it in the calculator, but exactly 6 by hand would be 12, choose 6, times 2/15 to the 6th, times 13/15 also to the 6th, okay? Remember, these two things add up to 1, and these two things add up to the sample size in question, which is 12. And there's the answer if you want to do it by hand, okay? And again, one last reminder, this could be written as 12 choose 6 like that, 12 over 6. It can be written like that. Okay, exactly 1 DUI accident. Okay, exactly 1 DUI accident, no problem. Okay, this will be written as 12 choose 1 times 2/15 to the 1st times 13/15 to the 11th. And that will come out that answer. If you want to check, go ahead. Okay? Now, at least 3. Come on now. Go. At least 3 DUI-related accidents. At least 3. At least 3, the complement of at least 3 is 1 minus 2 or less. Remember, the cumulative function, the C right here, is an or less function on the calculator. There is not an or more function. There's not. So 1 minus 2 or less. Okay? So I'm going to accumulate the probability of getting 2 DUIs, 1 DUI, no DUI accidents. So I'm going to go 12, that's the sample size, times, this is 2/15, okay, comma 2. And that's going to add up 2, 1, or none if you use a CDF function. That's this number, you go 1 minus, you get the probability of at least 3, which is 3 or more. Okay, at most 5. At most 5 means 5 or less. You got to put all of these into context of or less function, or an or less or more function. Okay, at most 5. That's 5 or less. There's the CDF, 12, 2/15, 5. Really good chance of getting 5 or less if you think about it. What's the mean? No problem. 12 times 2/15 is 1.6. And the standard deviation will be the square root of 12 times 2/15 times 13/15 and that's about 1.2. So although this average is 1.6, it deviates almost by a pretty big number of 1.2, okay? All right, now we're gonna go ahead and move on to some other problems in this set. Okay, a certain university approximated that 12% of the 8,000 students they accepted this year will not attend. Okay, so sometimes kids are accepted, they don't attend. They'll go elsewhere. So they extended acceptance letters to 50% of their 2,000 students on their waiting list. Okay, and they're assuming they have a 95 chance these kids are going to accept. What is the probability that more than 8,000 students will enroll in the university this year? This problem is actually, there's a lot to it here, okay? First of all, let's figure out, they're not going to go over 8,000. So 12% of 8,000, if you multiply 0.12 times 8,000, you're going to get 960. So that's the number of open spots we are dealing with, okay? Now, of these 960 spots, we are going to invite 1,000 more people, which is 50% of the 2,000. That's going to be 1,000 more people. And their probability of success or going to the university is 0.95, okay? And we want to know what are the chances we go 960 or more. Well, off the top of my head, okay, I'm expecting around 950 of them to accept, because the mean of this situation is 950. 1,000 people were sent, hey, you want to come to our university? And they're going to accept at a 95% rate. So right there, that's 950, okay? So this has a chance of happening, but not necessarily a great chance. Okay, so what we're going to do then is we're going to set up a binomial situation. This is binomial because the probability is 95% for every person we believe. There's two outcomes. They accept the acceptance or they don't. There's a set number of trials. We set out exactly 1,000 acceptance letters, right? 50% of 2,000. And everybody's choice of school is basically independent. Not perfectly into they want to go with their friend or whatever, but it's basically independent. Okay, so now that we're going to do the math here on this, pretty simple, okay? The math on this is going to end up being, we want to know the probability that we are going to more than 960 will come. So I got to figure out the probability of 960 or less coming. And then I'm going to go 1 minus that because that's more than 960. So 960 or less. That's the CDF button on your calculator. And that is 1,000 letters went out at a 95% rate, they'll accept them, and 960. And then I'm going to go 1 minus that, and we're going to end up with this answer. Okay? This is a similar problem. Our parking lot has 300 parking spaces, 20 of which are designated for handicapped drivers. The typical number of cars during a peak is 280, with approximately 8% of those drivers being handicapped. What is the probability the handicapped driver must park in a non-handicapped spot? Similar idea. How many spots are we talking about here? We're talking about 20 spots. That's going to be, that is 20 of which are parked for handicap, right there, 20, okay? And we know the probability of the handicapped driver is 8%, okay? So what we're looking at is we got to figure out the probability of 20 or more people coming in that are handicapped. What's the probability of that? And that's, so I'm going to do the CDF function again, okay? So this is binomial CDF. 280 is the total. 8% chance of being handicapped. And 20 is the number. So if 20 or less are full, and we go 1 minus that, then that means we're overcrowded, okay? There's actually a pretty good chance of it if you put it in your calculator, okay? All right, now, the last problem of the day, of this day 6, I should say, I'm gonna do this on the calculator, okay? And I think you're gonna get a lot out of this, all right? So I'll be out of the picture here in a second. Okay, first let's read the problem. if a tennis player's serve percentage was 85% out of 10 serves, find the probability of, and then I have all these questions. Okay, this is great. What I'm going to do for you is I'm going to actually make this whole distribution, which you have in front of you, but I'm going to make it on the calculator, okay? Okay, the first thing you do is you got to go to L1. So get to L1, and this is where all I want you to do is simply type in all the possibilities. When a tennis player serves, you're going to type in serves 10 times. 0, 1, all the way to 10. Okay, now I'm going to go over to I'm going to go on the L2. And on the L2, I'm going to type in a command that says to the whole distribution what to do. Make sure you're on the L2. So go second vars, which is second distribution, okay? And arrow down to binomial PDF. Binomial PDF. And hit enter, okay? And I'm going to tell it. Now you may have to put commas on your calculator. We're serving 10 serves, okay, with the probability of success of 0.85, and we are looking for L1, second and the 1 button. You're going to tell the whole distribution what to do, and you'll have it. So that is the probability of success for every single one, okay? Now notice some features of this. Let's go down a little further, okay? I want you to look at this as you go through yours, okay? We know the mean number of first serves in will be 8.5. That's 10 times 0.85. And look at the most common, the mode would be 9. 9 has a 35% chance of happening. Going 9 for 10, when you should go 8.5 out of 10, is the most common. The second most common is 8. So the mode of this distribution is 9. This distribution will also be skewed to the left because the smaller numbers are less likely to happen, okay? And if you notice, the mean is to the left of the median in this case. Okay, so from here you can actually answer a lot of these questions. But let me show you something else you can do. Let's go to L3. CDF, 10 trials, probability of success 0.85, and this is L1. I'm going to paste that thing. All right, this thing will add to 1 because 100% of the time, this guy will serve 10 serves or less in out of 10. 80% of the time, he will serve 9 in or less out of 10, etc. So this is the CDF function. Now with these in front of you, I'm going to go back to the regular screen. With these in front of you, you're going to be able to calculate these real quick. Okay, The probability of making exactly 7 serves, you have it right here. This is on the the PDF function, the PDF. It's going to be right there, okay? Making at least 7. At least 7, you could add up 7, 8, 9, or 10. You could add those up. You could. Or you can look at the CDF function and realize at least 7 is 1 minus 6 or less. And 6 or less, if you're using the PDF function or CDF function, 6 or less would be right here on your calculator, okay? So you're going to go 1 minus binomial CDF 10.856, okay? And that I guess I have that written right there. That'll be easy, okay? All right. Now, find the mean. There it is. Find the standard deviation. This is old hat. We've done this before. Find the median. The median is where this distribution crosses the 50% mark. So if you start adding these numbers, it finally crosses 50% when you add this 0.3474. That makes this the median. Looking backwards, you can also tell. If you add these two numbers up, you get about 53, 54%. So in the 9s is where it crosses the 50% mark. So this box plot, this would be the median, okay? And the 75th percentile might actually also, it's also a 9. This is a crazy distribution. It's so super skewed to the right, or left. Super skewed to the left, okay? It's a bad drawing. Okay. Last one. What would be considered outliers? To me, the best way to do outliers is take the mean, okay, and plus or minus 3 standard deviations. We calculated that, and these numbers are considered not outliers. So the ones that are outliers are 0, 1, 2, 3, 4, and 5. 0 through 5 are outliers. There's nothing over 10 anyway, so the only thing normal would be to serve 6 in, 7 in, 8 in, 9 in, or 10 in. All 5 of those are kind of normal. This would be considered abnormal. 5 or less is abnormal. Okay? Last problem. Perfect timing. Your college acceptances. If your college acceptance rate is 67% out of 20 applications, find the probability of getting into at least 10 schools. This distribution is 21 numbers long. You can get into 0 schools all the way to 20. So that's 21 numbers. I'm not going to build that big old chart like I did on the last problem. Okay? What are the chances of getting into at least 10 schools? At least 10 is 1 minus 9 or less. And there it is. 20, this is binomial. Okay? Hubble is the same for every school. In theory, we're pretending, 0.67, probably not, but in theory. 2 outcomes you get in or not, okay? Set number of trials, you applied to 20, and independent. Every school is independent, okay? This is probably not exactly binomial because different schools have different acceptance rates, but just look at it, it's close enough, okay? All right, so there we go. 20 schools, 0.679. If you go 1 minus that, there you have it. Okay, getting into all 20. This is you can just go 0.67 to the 20th because you have to go 20 in a row. You can do that way, or you could do it this way. Exactly 20. 20 schools, 0.67, getting into exactly 20. It's obviously very unlikely. All right, good luck. Thank you very much.